Thanks, Pearl. And if anyone has any questions, Pearl's going to come around and help. And yeah, let's talk about creating data for ML. So my name's Nick King. I'm Chief Product and Marketing Officer at Snowplow. But before this, I've spent 20 years building platforms. Azure, parts of Google Cloud, VMware Cloud, and most recently at DataRobot, working on ML platforms, and here I'm at Snowplow. And I discovered Snowplow in a really interesting way. I was building a number of novel sort of use cases around marketing, around go-to-market and prediction for sales performance. And I found that every time I'd go build these models, the data preparation would send me off a cliff. I spent so much time doing data prep that I kind of rage started using Snowplow. And I thought it was just a thesis, would it actually go and drive better predictions? But it turned out every time I used Snowplow to create this data to go drive predictions across multiple go-to-market channels, it kept outperforming anything I'd ever done before. So I was like, I met the folks from Snowplow, I started talking to them, and here I am today. So a little about Snowplow. Snowplow is what's called a behavioral data platform. I'll explain what that means in a minute. And really it focuses on giving everyone the capabilities on how to build very descriptive ML AI-ready data that can be scaled across any model. Today there's tens of thousands of open source customers. We generate roughly about 1 trillion or a couple trillion of events each month. And in our commercial platform, we're around 250 million events. So already today, as Snowplow, it's already generating vast amount of data across the internet and across companies today. So what we've seen as a shift, I'd say, the last 5 years, is customers have been moving more and more to what I call data products. And really this sort of simplified down means that our data warehouses have become so sophisticated that we've moved more of the application and processing to be as close to that data as possible. And then those data products are served out to other applications, either as APIs or surface as other components of applications, to really speed up that process of getting insights from data, driving inference and producing that and sending it to other applications. Two of our customers that do that I find quite interesting. One is AutoTrader. And what happened was the engineering team decided to work much closer with marketing. So they directly connect their system into their marketing team and actually run full real-time, what I call composable CDP. So effectively a CDP across their entire customer base that activates their marketing activities. Another solution is called Strava. Strava is this fitness application. Some of you may have heard of it. But Strava instruments their entire platform using Snowplow. And so everything from their DevOps instrumentation through how their applications work, to the user data of how fast they're running, the different segments, everything is instrumented on Snowplow, orchestrated through the pipeline and goes back to one common schema. And what that means is everyone at Strava is able to use one common way of managing the data and one common way of publishing data apps back to their applications. So all of us have been around and heard the concept of big data. And I think one thing that I've learned over the years is that you can have lots and lots of data, but nothing's better than really good, specific, descriptive data, and then you can use a lot less of it to be performant. A number of us are pushing for as close to real-time use cases as possible, and that requires you to have much more discrete data or minimum effective data to drive that inference. And so this sort of set down the path of where we've been going with Snowplow. How do we figure out how to get the most descriptive, accurate, small amount of data to drive these decisions? So let's look at the problem today. Today we source much of our data from exhaust, right? We usually look for third parties that may have some indication of what might be happening, and we begin to extract that data, transform that data, and then ideally that has some insight that allows us to drive predictions or drive insights across that use case. So this is a pretty common scenario. I'm not sure what's happening, but I hope this doesn't explode. What happens with this is you have lots of applications, you're always sourcing this data, and then you spend a lot of time cleaning and scrubbing the data. And that naturally means that you introduce bias to the data, and it also means you might lose other signals as you go through and clean it. But I'll give you an idea of what this looks like in a little more detail. We see that data is not only hard to get, but often it's hard to understand. You know, we all see the column names that mean nothing, right? They're sort of like a hash, or someone's used another column name and it gets renamed like user number 3, company number 5. And then it also requires significant aggregation to be usable. So one of the concepts we look at is what I call data altitude. So as an atomic event, a specific time-stamped event, is an aggregated event which was rolled out every minute, Or is it a series of events that are happening at some infrequent way and are out of time series? It's really important with time series data to make sure all of your events are specific atomic events, because that is where a lot of your noise comes from. And when you're converging multiple systems, they all have different altitudes, which introduces more noise to your data set. And then the other thing that's becoming really interesting here is that this data is becoming more and more required to stay within data sovereignty rules. So data has to stay within Europe if it's being through Europe, or it has to not go through third-party sources. And so you're finding that a lot of this data has to actually be excluded from how you're engaging customers or making decisions. So this is a pretty common what a table might look like, right? You extract it, you see things like weird caps, you see, not explaining like who knows what true or false is. You see weird timestamps that are hard to aggregate, and then you get, potentially compliance risks with IP addresses, other PII data, and then you get the lovely like question mark random data. And this is what we're often working with. And the tricks we use is usually we drop whole columns to clean the data up to make it more worthy. But it doesn't actually help us long term to work this way. It requires anything to be maintained and managed. What happens if something changes upstream? That whole schema then becomes invalid. You have to start again. So that led us to this concept of the difference between data extraction and data creation. And the real shift here is when you move to a creation approach, you really shift to what I call create and consume. So on the left-hand side, you see a pretty typical process that we would go through and do data engineering. You'd go through, extract the data, you prepare the data, you'd then go through a multiple set of steps to get it ready as a table, and then ideally get it ready for feature engineering and model training. But when you use the Snowplow approach, the data creation approach, you create one large dynamic table that can keep adding to the schema, and everything is an atomic event. And what's elegant about this is then you can aggregate those to be feature tables, or you can aggregate them up to be metric tables. And so this data is already in a descriptive format that can be quickly modeled. That means you can use less data to get models, but it also means you've got a lot more time and a lot more consistency across your entire organization as to how you go do that modeling. So data creation has a lot of technical and practical advantages. The first thing is that data intelligible? And this thing is sort of underrated. We say this a lot, and we say, hey, we want this data to be descriptive and be understood. But think about the last time you looked at a data table and tried to make sense of it. If you've worked with it for a long period of time, you probably recognize the columns. But if you were to give that same model, that same table to somebody else, they'd have to go through the same learning and might interpret it totally differently. What happens with the way that we create data is each column is described with a specific data language and grammar. And we use real words to describe it, which means it's very easy to understand. And I'll show you some examples of how we take human language and translate that into a universal data grammar. The other thing is the ability to evolve schemas over time. And I think a lot of us have got away with this concept of write first, schema second. That's kind of how we got away with big data. We spent a lot of time trying to go back and infer schema or figure out what was happening with schema or transform it into some level of data clean room or some level of gold record. But what if you always ensure that everything that entered your pipeline, into your data lake, was always compliant, and anything that wasn't went into a bad data queue, and then you could mend the schema and then bring that data into your data warehouse? What's cool here is, let's say I was a chicken farmer, so I'm describing chickens and chicken feed and lighting, and then I happen to buy a steel mill. Now those seem like two pretty hard schemas to manage, but because I could add those two things into the schema, we would dynamically add the columns to the table and allow you to manage all that together. And so then you can also go back and fill in different fields using enrichments to bring that together. So that flexibility is really key. It also, because it's in a natural language, it means multiple teams can work together to maintain that schema. And if you think about how many data engineering teams work, there's usually one person that's authoritative on the schema, and it can also honestly be quite a complex task to convince them to change that schema and make sure it's well understood. The next piece is compliant, and making sure the data is not just secure, but removing for bias, but also looking to make sure that it has stayed within the right location. I really do expect us to see much more data sovereignty and nationalization of where data lives. And it's to the point where I think we'll actually see ourselves, the data teams, being very accountable for making sure that data doesn't leave the wrong data center and lands in the right location. And it needs to be auditable as well. What's unique about data creation is you can also do first-party end-to-end. And so what happens generally is you have a lot of third-party programs or technologies providing that type of insight. But once you introduce a third-party tool, you're now having to assume or work with them to ensure they're compliant. Even just this morning, Italy released an entire sort of point of view on Google Analytics and saying that customers should no longer use Google Analytics in Italy. And like that puts a whole lot of uncertainty as to, okay, if you're using that data, do you have to then go remove that from those spaces? And we're seeing a lot more of that. The next piece, which it starts to get really cool, is once you know the schema and you control the pipeline and those events are atomic and predictable, it means you can start to drive much more real-time activation and processing. So the way that we build this means that you land both in batch straight to the data warehouse, or you can have an actual event stream that can be driving activation. So there's a couple uses that we see for this. One could be looking for fraud or malformed packets or attacks. Quite often you'll see that payload inside the data stream, and you can make an action to say, hey, go back and check to see what's going on here, or lock this account. The other thing for real-time, and we'll talk a little bit about how we structure data, is in the real-time space, you can start to take the system data, the demographic data, which is who it is, the transactional data, and the behavioral data, which links them together, and you can use all of those to drive inference and behavior and react to those accordingly. So a typical scenario here might be dynamic paywalling. So if you have a paywall product, you could dynamically adjust that. Or another thing that we use it for is looking how you dynamically adjust the propensity of that person to convert, and each action can change the propensity model. And then finally, trusting the data. So what happens here is you end up with a descriptive data warehouse or a data structure or a data grammar that describes your business, which becomes the sort of the key way of explaining everything. And what we see today is there's all these attempts to build master data structures and bring that together. But when you take this approach, the grammar is always expanding, so it's always the most informed way of explaining what your business is doing. So how does this all come together? And so you see a pretty simple architecture diagram here. On the left, you see where we generate the events themselves. And so we have a number of SDKs, webhooks, ways you can create that. And effectively from there, you can generate the data and it then goes into the pipeline. And then the pipeline has this ability to unify the events, validate them so it makes sure that they're in the right time sequence, make sure they're matching the schema. It looks to see if the data itself is as expected. And if it is, it passes it through to then go and enrich it, which we bring in from third-party sources, and then drop that through privacy controls before it's written to the data warehouse of your choice. So in this case, we just released a Databricks loader, which is designed to drive highly scalable event loading. And you can effectively guarantee everything that enters into your data lake or into your lake house, that everything is conformant. Then what you see us do is the modeling phase. So we have the ability to resolve IDs, do filtering, do aggregation, because remember, everything is atomic. You want to aggregate up sometimes, say, okay, this is what happened this day, or this is how I bring these events together. And it then creates two types of event streams. Hang on one second. One, the real-time event stream, which is basically to say, okay, here's how we pick that up. And then event forwarding starts to look for an activation to happen from there. So that could be you kick off a training job. And particularly as you move more to real-time ML type use cases, it's very hard to figure out like what is the time frame you want to be retraining. But in this case, because you're using small and very accurate data, you can make decisions whether you think that model is drifting and kicking off training jobs. You're also able to measure, so not only do we do feature table generation, you could also generate a metric table. And particularly in BI use cases, this is a very quick, accurate way of doing that, and if you were to add more to the schema, you can quickly redo those models and actually go to this point of product managing those data products and providing them to the organization. So other teams can pull that data and also inherit that same schema management and that same modeling you've been maintaining. Across the bottom, what you see is how we bring it all together. So we have a UI and API framework that allows you to manage this. But we manage things like data quality. We have a data catalog, so you can see how those are moving. We also have a tool that goes through and helps you remediate issues in the schema. And so for us, evolving that workflow on how to do schema management really helps you maintain trust, but also helps different team members work with that. And of course, there's monitoring, alerting, and configuration. A lot of the customers we see are generating billions of events a day, and so you want to have the ability to see what's happening, what parts of the service are being delivered. And at the bottom, we have this technology called Igloo, which we don't talk about too much, but what Igloo does is it's our dynamic schemaing technology, so it allows you to continually extend the schema as you need to. So when we look at the data, we also end up with what we call behavioral data. So because you've got the consistency across the platform, behavioral data has a really interesting outcome. So when you think about how you structure data today, usually you're trying to put some level of payload and timestamp together. But when you have the ability to maintain the whole pipeline, you can be much more sophisticated here. So we like to think of it as 4 layers. First is the systems data. What generated the data? Where did it come from? What time was that? The transactional data, which is usually the payload. It was a Visa transaction. It was $50. It was for a glass of water. Demographic data, which describes who they were. It could have gone and enriched that from somewhere. It could look at where they were, where that data came from, so you could go like Salesforce or different systems, and it also creates that perfect row. And then finally, the behavioral data. And think of behavioral data as the graph link between each row. So you can say, okay, this event followed this next event. And what that starts to do is starts to give you not just the context of that point in time, but what events were related to that previous event. And for ML use cases, and I'll show you a little bit as we get into the data, ML use cases, this behavioral data becomes incredibly informative because you start to understand what were the precursing events, what changed, and then the other thing we do is we actually measure the time between those events. So another thing, because the time series data is all consistent, you have beautifully cleaned features that you can work with how long it took between events. So let's get a little bit into what behavioral does and how that actually performs in AI. So on the left-hand side here, what you see is 2 English gentlemen. They both own castles. Just one happens to eat bats. But the difference here is that you wouldn't know if you just looked at the demographic data, right? You wouldn't know if they're actually different. Like on just pure demographic data, you don't know who they are. And so you want to start to add different elements to that. We used a retail use case here. In the retail use case, you can see that there's multiple things happening, both online and offline, but you're able to stitch these together and understand the entire journey. And even after something has happened, the sort of target feature has happened, you can go back after the fact and restitch that back together. One example that we have is a glasses company. And so you can choose your glasses with them online. We'll actually look at how they do their VR for those glasses. We'll figure out when someone comes into the store, and we can stitch all 3 of those experiences together and give a full view of the customer. Hang on one second while I cough quickly. Excuse me. So when you have these rich experiences that all come together, not only do you just look at the online, but when you create data across your store experience, your retail experience, and you bring it all together, you get this beautiful picture, which is, as I said, very good for ML. So what I did was I put together this animation, which just kind of explains how we take this. So we take normal language. We then basically create that and look at how we create the schema, and then we use that schema to create a very descriptive data warehouse and table. And then we ensure the time is always accurate, and then we're able to go and query this as we would a large table inside Databricks. And if you were to say, if Courtney wants to suddenly move to Austin but wanted to know what car she was driving, we could add that and would add that to the table, enrich the whole table. You've always got this consistent feature table to be working from. And we do this at massive scale. So you could choose to have a very small effective piece of data, or you could start to train across the whole data itself. So you're probably wondering what this looks like when you start to put it inside a Databricks environment. So generally, this is what we tend to see. On the left-hand side, you can see how we generate the different data types itself. We then have the Snowplow engine, which then goes and enrich the model, the governing piece I talked about. And that then loads these atomic events inside of Databricks. In this example we used, we're going to use a web example, because it was the data that we pulled for this. We then use a DBT model, which we provide, which aggregates the web statistics in a way that's usable. And that gives you a series of modeled data, which is page views, page web sessions. We then pass that into Databricks and Worksheet. We then train across that data, and then we publish those out and creates a bunch of propensity scores and also can drive analytics. So effectively what we're doing is we're loading into Databricks this really clean view of all the data you're creating, but also allowing to maintain it across all these solutions. And then you get these very interesting propensity scores that are using the full life cycle of that behavioral data. We're also able at this point to use existing ML flows you might have in place. And so what we see sometimes happen is you'll build out the Snowplow version of the data, you'll put it inside Databricks, and then you'll start to look at what other things could you bring towards it. And one typical scenario we hear about is composable CDP. So, customer data platforms have been really interesting. We hear a lot of talk about golden data records, how those come together, but I think where a lot of data engineering view of how CDPs work is you want to bring the whole CDP into your data warehouse and really be able to manage that data as the customer data platform and then serve that data to different systems and applications. What's always concerned me with the CDP market and how we think of customer data is different organizations, different platforms try to lock up various pieces of that data. And you spend most of your time trying to stitch together like the support data, the sales data, the web data. And very quickly, as a data team, you lose control of that data, and you're always kind of tracking and trying to bring that together. When you do it this way, you're able to create that table that's growing, bring in other sources of data, and then really start to evolve the way you think of a customer data platform across your organization. And then you can then inject those records back to, say, a Salesforce or a Zendesk, wherever you need those records to be. And as a data team, you start to manage that data very specifically. So this is a pretty typical Databricks deployment we see. On the left-hand side, you see the data collection, the data creation, and then we usually see like a 5-train coming in and pulling the different data sources and moving that into a table. Then within Databricks, we see the source tables coming together, joining together, and then we have this concept of a custom golden record managed inside of Databricks. And then usually with an activation tool, such as HighTouch, you'll push that data back into these different platforms, and you have this really clean data-first approach to how you're thinking about customer data. What also we see happen is once you get this flow in place, you very quickly start to add in new services and more data to it. And then once you do that, what you see is the data activation, what you actually use that data for, starts to change. So the first thing we usually see is, okay, let's do reporting. And reporting is a good state. You have like a true view of your customers. What are your customers doing? The second phase tends to be, okay, can we take action or build ideas around what's happening with this data? So we see them see models start to be built like, okay, if this is happening today, should we send something out to tomorrow? But as confidence grows, we start to see real-time use cases begin to emerge. So can you train and drive some behavior like, okay, this customer is engaging us, they've come back 3 times, perhaps we should send account-based marketing to them. Or this person's walking through, been touched the support site, they've tried calling our support line, those 2 records come together, something might be happening, the AE should know about that, or the support team should know about that. And these scenarios, they sound like they happen all the time, but they're very hard to establish in a real-time function. And because you can control the data and inject it back into these other systems, it very quickly becomes a scalable way of driving very specific actions and outcomes and being able to track them back into the system. So it totally changes the way you think about how you manage a CDP. So on the ML side, what does that start to look like? So this is actually some of our data. You can see the white stripe in the middle there. That's when I broke some stuff. You can see that time is clearly constant. But then also what you can see is you see these long lines which are happening. What those are actually campaigns that are landing and creating a lot of demand on a single day. And so you can see across here, because the data is so structured, usually you'd have a lot more noise in this data, or you couldn't quite trust, okay, was this data actually part of this campaign? How'd this come about? And this data is actually accurate and specific enough to be directly actioned. So we now know that based on this, we know which campaigns tend to work. The big line there is actually a campaign where we go through and demonstrate the product in depth. We know that has a really successful way of converting. There's a couple other ones which are earlier on. Those were really around some webinars where we introduced new ways of delivering the platform. And so we know that those drive engagement and can convert. And over time, we can start to look at multi-touch attribution for that as well and begin to predict how these customers are performing. So let's get a little bit into, as you get more sophisticated with this type of data creation, what begins to influence the model. So the first thing is, what you'll see here is the SHAP analysis of how we see different pieces. And you'll see that we actually take not just the title of the page, but also how long they're on site. We look at the campaign that's going there, and we also look at where which region's been impacted. And you can see all the other features that we're tracking. But what's really interesting here is that you can see, trends inside the market. So right now, we're seeing a lot of trending data around data as a product. It's one of our largest conversations we're having right now. And you hear data apps and data as a product and data product management, but it's really become very interesting as this is a key trend for us, which means, okay, we know to go invest in this, we know to build out much more depth across this type of technology. On the right-hand side, you can see other features and what the feature importance is. And remember how I told you we look at the time between each event? We looked at that very specific behavioral data. Well, it turns out engaged time but absolute time were really important. And so we could actually look at, okay, how long do they engage those events? And this is a sum of multiple visits. And so typically you're not able to do that level of precision because not everything tracks the same amount of time. The other interesting one here is you see vertical percentage scrolled, and that's people scrolling down our pages. That sounds like a pretty weird thing to track, but it turns out our audience is very technical. So when we had a marketing website, like Little 2 Marketing, we found that the scroll down the really technical pages. So what we learned was people wanting to learn how to do data as a product wanted more technically deep pages. They wanted to be able to go through and read everything in one go. And so we started to change the way we did that. And that breaks a lot of concepts that exist today and how marketers are told to go do that. But we know that data engineers want to have one page, scroll down, come back, scroll down some more, scroll down some more. We know if they do that over a period of time, it's highly indicative that we probably need to go back and help them some more. None of that is possible when you just take data exhaust. You could stitch it together, but for us, we just add a new feature to that over time. So a totally different way of thinking about how you manage data. This was an easy sort of to understand use case, but we see more and more of these across security use cases. We're seeing interesting ones pop up in oil and gas. We're also seeing it for healthcare as well. So there's just so many different cases that this makes a ton of sense. And it gives you the confidence to treat your data warehouse as that center source of truth and distribute across your organization as these trusted data products. So I want to talk a little bit about the type of apps we have and what we're seeing. So the left-hand side is the marketing one. You've probably seen these all before. Behavioral profiling, personalized advertising. That's all cool, but what happens, as I said, is you can get to real-time personalization. So we actually have media companies that are dynamically changing their paywall. So based on some content performs well, some content performs badly, they'll dynamically change which content is inside and outside the paywall based on what's happening that day. They'll reorganize their entire newspaper as well, like where content sits on the page, and that's all happening dynamically. And usually that happens, like it would take like 1 or 2 days, or it's done more on intuition. But because we can provide that data in real time and be very descriptive, it's had massive implications for how these papers are working. On the product side, we're actually seeing the products evolve as well, and a big focus here on recommendation and search optimization, but also A/B testing. And because we deliver the data in the data warehouse, there's no extra tools that have to be sort of managed across the organization. And that really means that if your engineering team is working closer with the product team, they have access to the same data structure, they have the ability to drive results from that data structure, and there's no sort of like multiple tools across the organization trying to solve the solved problem. The sales ones, I think, are pretty self-explanatory. The customer ones, again, pretty self-explanatory. The compliance ones are really interesting. So, looking for vulnerable customer detection, which is looking like, okay, has someone been logging in multiple times each day to kind of withdraw the maximum amount from their credit card? Are there different behaviors where someone's like logging them in from a different computer and maybe they're like, something's happening there? Consent tracking, so making sure we can see the consent across everything. Fraud detection as well as threat detection. And these use cases are really scalable as well. We actually see in our pipelines, because we recognize that we control the schema, we can see when someone's trying to attack and use those different pipelines to see if they can exploit those. And so we actually push that data and it doesn't get pushed into the data warehouse. But you could see examples here where you could actually start to say, okay, is there likely to be multiple attacks based on how this data is coming through? And sometimes the discarded events are just as interesting as the actual accepted events. So there's a couple use cases we see a lot that I thought would be fun to kind of talk about. So one in healthcare, something that's really unique because of the way we control the pipeline is we're the only HIPAA-compliant end-to-end solution here. So it means every step of the way you can maintain the confidentiality of your users, the healthcare practitioners, with the data. This also extends to GDPR, California, and we're the only one that will work inside of what's happening in Austria and how they're starting to move there as well. So there's more and more laws coming in about controlling customer data, but also we expect it to be a lot more of this. As I said, Italy changed today, but I definitely think Austria, Germany, and a lot of the Nordic countries will start to implement this as well. On the media use cases, media has evolved so much, and there's so many different platforms, but what we see is there's a level of sophistication with media customers, where they start off with these platforms, they start evolving, and they have multiple organizations, and then it becomes impossible for them to maintain all those organizations. And what we've found is when they can bring together the subscription teams across multiple assets, they can be much more effective and know when to bundle, when to unbundle. And then finally, retail. There's so many use cases around behavioral data for retail, but I think what's getting more interesting with retail is understanding multiple ways to engage these customers and how to make that full lifetime journey one that's really valuable to these customers. I think for the longest time, marketing had focused a lot on acquisition, and we're starting to get better at how we sustain. But in the retail spaces, I think there's multiple journeys we can start to look at across this. And as I said, because of our ability to do server-side tracking, that really does mean that we can do it full first party. So things like ITP and all the cookie deprecation stuff you're hearing doesn't affect us. So I want to talk a little bit about what we've been doing. So we've been around for a little while. Today there's about 10,000 customers using the open source or our platform products. It's pretty hard not to find a customer that has used us and has been in a different industry, which I really enjoy. The open source code is there, so it's on GitHub if you want to go grab it and take a look. But we also learned that there's an opportunity for us to help our customers out more, and so we also have what we call a behavioral data platform. And so things like setting up the pipelines, how to scale them, our help to sort of get you into some of these more complex use cases is something we really take pride in helping you with. But of course, if you're going to use the open source, we're very excited for you to do that as well. So our behavioral data platform has 4 pieces to it. Effectively, the console, which brings it all together. We have a data governance portion, which allows you to really define the policy and make sure that no bad data gets into your pipelines. We have this concept of data product management, which is all about the life cycle and workflow of your data, but also how you can begin to publish data products. And then what's really unique here is we run a private data fabric. So you actually don't run Snowplow in our cloud. We actually deliver it into your VPC. So if you're using AWS or GCP, we'll actually drop in Snowplow into your infrastructure, which means you have complete control. The data runs all through your side, which for a lot of customers that are moving that much customer data, it's a really powerful approach. And we'll then maintain and make sure it's up to date. We'll make sure it's maintained securely. We'll make sure it maintains uptime. So how to get started? So we have the quick start. So we actually have an open source quick start. We made that pretty easy. You pull it down, you boot it up, you can get going. That's on GitHub. We have a try Snowplow. So if you want to try it, we'll set you up. We'll bring you through and show you how to use it. We're also here downstairs in 832. Come chat with us. Come chat to me if you want to geek out. We love doing this stuff. In fact, there's a bunch of Snowplowers in here. And just come ideate. We love seeing this happen. And every time we do this, every time we sort of push ourselves a little more, we keep finding new use cases and we keep beating our previous score of like how predictive this data is. So it's a pretty cool experience. We're pretty pumped about it. So with that, I'm going to hand it back to Pearl. Pearl, did we have any questions? Any questions at all?
I didn't see any. Were there any questions for Nick?
No. We nailed it.
Cool.
We did it.
Thanks so much, y'all, for coming.
Thank you.
Give him a hand.